All right. Who can tell me how to find the inverse? Marco. Switch y and x. Very good. And so how did you solve this? Yeah. Perfect. Then what did you do? Divided by x. Move in. Then what did you do? Added 8. Then divided the whole stinking thing by 7. Well, that's somewhat true. Except, how do you combine those fractions? Yeah, exactly. So basically, just tack the 7 onto them individually. So that's 7x and 8 over 7. That's right. So it would be C. Charlie. Now, I've specifically, what I did was, like I do every time when I make a test, I go through and for every group of problems, I put one straight on the test, one on the review of the exact same batch. I tried to put all the ones with the harder algebra on your review so that you've seen the worst possible scenario. But this is the most complicated thing you'd have to do as far as multiplying by an entire binomial and divide by the x. The one you have probably won't be quite that complicated. But are there questions about the process that we took or anything like that? Anybody? Ooh, awesome. All right then, number 2. What I've done for this review is I've hidden the questions, and we're going to read them, and you're going to tell me what they're going to have to provide for us. If you can read the directions and know exactly what you're supposed to do and what they have to give you, then you'll be so set tomorrow it won't even be funny. Erica, do you want to work on your review stuff? Okay, you want to go do that? You just want to keep that thing from yesterday, or do you need a new video? A new one? Alright, so I want you to be thinking about that one for just a second. Alright, what's this problem going to look like, and what are we going to be asked to do? Who can raise your hand and tell me? Yes, sir. That's right. It is going to have 2 equations and a fraction. And what are we going to be asked to do with those equations? Which, thank you. Thank you. But, how do we do that? Just find the zeros of the bottom. Very good. So, what's going to make the bottom equal to 0? So, Justin, I'm picking you because you almost beat yourself up after the test we did this on. What is the vertical asymptote? Only 5. Why not 0? I know. Because the x's cancel. Very good. So that, remember, that won't affect your domain. If this was asking what's the domain of the function, it won't affect it. It'll still be without 0 and 5. But when it's vertical asymptotes, then it definitely applies. Yes, sir. You mean regardless of the x on top? Like this? Because it's what all x values could you plug in that would give you a problem in the bottom. If you plug 0 into that function, you'd have 2 over 0 times negative 5, which is still 0. That's why any x outside is its own 0. In fact, we did some yesterday where you had to graph big polynomials where it was like x cubed and all that stuff. That's why anytime you have an x, whether it's to the 2nd, 3rd, 4th, 5th, whatever, it represents a 0 of the function. Alright, now I know since I didn't provide hard copies, some of you guys are going to want to write these down verbatim, so I will give you ample time to do that today. Right, next question. For the given functions f and g, find the indicated composition. Jenny, what's this problem going to look like? That's right. It's going to give you 2 functions, and it's going to say what's f of g. Now in this one, I told you I would do this. I went ahead and found one that was like f of g of negative 4. That way, it both sees how well you can plug functions values into functions and do a composition. So, f of g, which one goes into which one? G goes into f. So, that will be x. Now again, I told you I tried to give the hardest possible algebra ones today. That way you'll have seen everything you might possibly see come tomorrow. The one tomorrow will not be this lengthy, but you will have to do some foiling and stuff. So, the first one. Actually, let's do this part first. -4. Where's a, oh yes, but I'm not even there yet. So first, f of g. We have to square the first term. So I have to take x squared and multiply it by all three. It'll be x, well, I'm basically multiplying these two things by themselves. So the first thing I'm going to do is take this piece, multiply it by everything. X to the 4th minus 2x cubed minus 5x squared. Now I'm going to take this piece and multiply it by everything. Minus 2x cubed plus 4x squared plus 10x. Now I'm going to take this piece and do it by everything. Minus 5x squared plus 10x plus 25. That's the foiling of the first part. Now, we still have a lot of like terms to put together, but I'm going to go ahead and do the next part. There's actually two of them. One, because when I took the x squared and multiplied it through, x squared times negative 2x was negative 2x cubed. And then when I took the negative 2x, multiplied it by through, and I had to multiply it by the x squared, and that's why I have a second one. Now I have to distribute the 2. That's 2x squared minus 4x minus 10, and then the minus 2 at the very, very end. Look at all those terms. We need to put these together. How many x to the 4th do I have? Just one. How many x cubes do I have? I have minus 2 minus 2. Is that minus 4x cubed? How many x squareds do I have? 1, 2, 3, 4. So minus 5 plus 4 is negative 1. Minus 5 is negative 6. Plus 2 is minus 4 again. How many x's do I have? Let's see, I have 10, 10, and negative 4. So that's 16. And then I have 25 minus 10 minus 2, so 13. Just combining like terms. That's all we did right there. Now what do I do now? Plug in negative 4. Yeah. Now the easiest way to do this, since you have a calculator, would be to just punch it into your calculator. Since you can use it, why not use it? And in my opinion, rather than literally plug in negative 4, let's just do, this is in my opinion the easiest way to do this. Graph it and then just trace negative 4. That way you don't have to worry about all the parentheses when you actually plug in negative 4 into this problem. Please make sure I punch this in right, since I'm not really watching. Graph, trace, negative 4, 397, which would be C. In my opinion, that's the easiest way to punch those into the calculator, to graph it and trace it. Raise your hand if you have a graphing calculator. Okay. I've only got like 17 or 18, but if we need a few more, I can possibly borrow some. Okay. Any questions about this problem, about what you're asked to do, or anything? Do I need to leave this on the board? Okay. Next problem. Oh, I didn't bother covering this one up because the directions were too specific. Divide using long division. So that's exactly what we're going to do. Now, unfortunately, I did not pick one with missing terms because that is a possibility tomorrow. So don't forget to add in your zeros if you're missing any terms tomorrow. 16x cubed divided by 8x squared. That's right. Multiply it back through. Cancels. cancels. This drops all the way through. What's x squared divided by 8x squared? What? No, you can't do it if the x is too small. The number is, what's 1 divided by 8? 1/8. Yeah. Multiply that back through and you get x squared. Of course, I'll go ahead and bring down this -3. 1/8 times -24 is also -3. Hot diggity. So there's no remainder. Everything canceled. So the answer is A. Options C and D implied that there was a remainder, but there wasn't. Questions over that problem? Would anybody like me to leave this up there? No. Then I'm moving on. Solve the right triangle shown in the figure. What are they going to have to provide for you to solve for this triangle? They're going to have to give you something, either an angle or a side or something so that you can use SOHCAHTOA. So, here we go. A is 33 degrees. Side B is 45.2. And we have to solve for everything else. So, first, what's the easiest piece to find? Yes, but what I was meaning was, look, we have to solve for everything. Of the two sides of missing angle, what's the easiest piece to find? The other angle. Yeah, just subtract. What would it be, Diana? Oh, 57. Very good. Now, that immediately crosses off answers A and C. Now, from here, I think I heard somebody say tangent. Okay, you can pretty much use whatever you want as long as you set it up correctly. Tangent of 33 degrees equals opposite over adjacent. What mode does your calculator need to be in? Degree. So please make sure it's in degree before you tell me an answer. So take 45.2 and multiply it by tan 33, and somebody tell me what you get. 29.4. So the answer has to be B. You don't even really have to solve for C. Tan 33 equals A over 45.2. Are there questions about how we knew something or how we did something or anything? Well, first of all, once you got here, we just took 45.2 times tangent of 33. Make sure you're in degree mode. All right. Fantastic. The reason I'm just erasing this, oh, did I need to leave that up there? I can put it back up there. No? Okay. It's because this was a two-parter. There's another part of the problem. It's going to give you a different set of things. A is 11.6. C is 23.2. Let's solve for the angle. If I was looking for angle A, which is the easiest probably angle to solve for, angle A, which two sides am I given from angle A, Jocelyn? From angle A, which two sides are those? I'm looking for opposite, adjacent, or hypotenuse. Very good. Kevin, what trig function is that? Very good. Sine of A equals opposite over hypotenuse. So how do I solve for A? Sine inverse. Very good. Somebody punch in sine inverse of that fraction. Let me know what you get. Degrees. In the clue for that is in the answers. 30? Alright, so A is 30, which really only allows us to cut off answer C, which makes this angle, what, 60? Now from here you can do trig again, you can do Pythagorean theorem, you can do whatever you want to solve for B. But because we are kind of interested in trig, that's how we're going to solve it. So let's do this. What's that? Oh, I can cut off D. Good observation. Because those don't even add up to 180. What'd you say, Nate? You could. Absolutely you could. And you're welcome to do that tomorrow. However, I'm going to practice this. How about if we did cosine of 30 equals adjacent over hypotenuse? Somebody punch that in. 23.2 times cosine 30. I don't know. What's the answer? Well, that's true. It has to be B. How did you know it had to be B? What's another way to assume it's B once you've lowered it down to A and B? Very nice. This couldn't possibly be bigger than the hypotenuse. That breaks all kinds of math rules. I guarantee you know why they put that there? It's because somebody is going to say, oh, I have two pieces of a right triangle. A squared plus B squared equals C squared. And they're not going to think that this is the bigger side. I bet you anything, if you use Pythagorean theorem, if this is A and B, that's what you get for C. Because the book is sneaky. Yeah, go ahead. Let me know what you get. But I bet that's the case. And they did that just to see if you were awake. And if not, I have no idea where they got that. It is. Those sneaky test writers. So please be aware of that tomorrow. Questions over this problem? Or problems? 6 of the 21 down. We're 3/7 done. Yay! Next problem. Solve the rational inequality and graph the solution set on a real number line. Express the solution set in interval notation. What is this problem going to look like? That's right. But that's what the answers will look like. What will the problem look like? It'll be an inequality. And what are you supposed to do with that inequality? Find the zero. Well, you could graph it. Find the zeros and then put them where? On a number line. Very good. So, now there are glaring hints about what numbers to use in the answers. But what numbers am I going to need to check? 0 and -4. This kind of problem is like the only one where you have to find the zeros at the top and the bottom. Touche. You can knock out A and C. Ours shouldn't have brackets because we don't have an equal sign. Wow, I didn't even notice that. Very impressed. What's that? Well, that's not necessarily... You might have XX check. So we have to check the number line. So let's just use the number line on A since we... What's the easiest... Well, we can't use 0, can we? What's the easiest number that we could use? So we're looking at 0, -4. We can start on any interval we want. I'm looking at... I know we've lowered it to B and D. So what's the only difference between B and D? Less than -4. So let's just check that interval. What's the number less than -4 we can check? -5. -5 would give me -5 over -1, which would be +5. Is +5 greater than 0? Which would make this true or false? True. So it has to be B. That did fall in our solution set. And I'm guessing it would be check, X, check. Now, Ryan made a good observation. He said, well, how could there just be nothing here? Wouldn't it have to be either open this way or open this way? Most of the time, they will just alternate every time. However, when you have an asymptote, you can't just assume that. When you have an asymptote, then you might have back-to-back checks or X's. Also, if you have a double root. But that wasn't an issue here. Questions over this problem? About half your final is going to be chapter 4 stuff, since we didn't really take an official test over it. But anyway, questions over this? Determine the amplitude or period as requested. What's this problem going to look like? Blake, what's the problem going to look like? It might, but what's more likely that it's going to? What have we talked about recently that has amplitude and period? Who can help them out? What has amplitude and period? It's cosine and sine. It's probably going to give you some kind of sine or cosine function where you have to find either the period or amplitude. Which one did it ask us for? Period? Who can tell me how to find period? 2 pi over b. Negative c over b is the phase shift. So what's our b value? Negative 8 pi over 7. Now how do I divide a fraction by a fraction? Flip it and multiply. So cancel. Cancel. This reduces to 1/4. So, oops, that should go on the bottom. What is that, negative 7 over 4? Come on. Why isn't it negative? 2 pi over b. Yeah, it should be negative. Shame on them. They messed this one up. Good thing this is just the example. It should be negative 7 over 4, but shame on them for messing that up. So, negative 7 over 4. We did 2 pi over b, which is the formula for period. And this is our b value. So we divided them right here, Latifa. But then to divide fractions, you have to flip and multiply. So all I did was flip this one over. This is times a negative. That's what that is. And then I just did a bunch of canceling. That's all. Alright, so this is a two-part problem as well. The second part is find the amplitude. Sam, what's the amplitude? Very good. What about now? It's still 1/2. Very good. Don't forget that it has to be the absolute value, whether it is positive or negative. All right. Whether it's positive or negative, it'll always be positive. So watch out for that. Questions about anything you see on the board? The number in the front that's being multiplied. Anybody need me to leave this up there for a moment? Okay. Find a rational zero of the polynomial function and use it to find all the zeros. So what's it going to give me? It's going to give you a function. What do you ask? What do you need to find, Diana? Yeah, that's what's going to help us find the zeros of the function. Very good. And you could do it with your P over Q chart. You could do it with a graph. Now, it tells you which ones to check, so it might not even be worth it to graph it since we know it's either going to be, I think we've done this one before, 1 and -4 or -1 and +4. And if my memory serves me, I want to say it was the -1 +4 that worked, so let's see. So the easiest way and quickest way to do this is just use synthetic division. Drop the 1, multiply, and multiply, and multiply. Yep, it was. So we know it's not A or C, because it has to be -1. And obviously it has to be +4, so let's go ahead and take that out. Remember to take it out of your depressed polynomial. Now, Lynn, once I reach this stage, how do I finish this problem? Quadratic. Very good. I knew what you were trying to say. Perfect. Make a function out of it. Punch it into the quadratic. -b plus or minus b² minus 4. I have an email. AC all over 2A. I think that's going to be 36 minus 136, which is 100. What's the square root of negative 100? So y'all just wait for me to ask the question sentence. And what does that reduce to? Very good. And the answer would be B. B. Becca's bagels bounce bodaciously. I don't know. I couldn't think of another noun off the top of my head. Well, no, that was my adverb of how they bounced. My noun was bagels. I don't know why anybody would be bouncing bagels. But whatever. Anyway, questions? Could have said Bridget's balloon bashed Brianna, who's not even here, badly. Bruising. We're done. We're done. But I like y'all's enthusiasm. Okay. Do I still need to leave this up there? Let's do another one then. How about... I'm just kidding. We're not really going to do another one. Blake's brother bashed... I don't know. Why do you keep going back to bash? We're throwing out back. Oh, really? Blake's brother Blair beat Blake badly by... Bashing. No! We're not using bashing. By basketballing better. No, basketballing is not a real verb. By b-balling better.
By beating, like with bash.
Oh, with doesn't have a B in it. You cheated. Alright, here we go.
I don't know. I thought it was...
Find the exact value of the indicated trig function at theta. What's it going to look like? It could. In fact, I don't even remember it. It could be a triangle, or it might just be like something like secant of 3 pi over 4 or something. Oh, wow. I didn't even remember that it was secant, or over 4. All right, now, why do you think they gave you the fourth quadrant? That's right. Fourth quadrant means we're down here somewhere. You don't have to draw it to scale. If you actually draw it in that quadrant, it'll help you remember what's positive and what's negative. What does secant stand for? Cosine, which means cosine would be what, 4 over 7? Adjacent over hypotenuse. Now we're asked to find tangent, which is opposite over adjacent. So it's going to be something over 4. So it has to be A or C. Well, I guess you could figure it out right there what it is. But how can we find the missing side? Pythagorean theorem. A squared plus B squared equals C squared. Just remember, whatever we get, it's going to be negative because it's in the fourth quadrant. So 16 plus B squared equals 49. Subtract, B squared equals 33. So this must be the square root of 33. Negative. Please do not forget your negative because it's in the fourth quadrant. Therefore, the answer is C. You're right. That would have had to have been what? Secant? No, cosecant. Never mind. 2. Questions? Concerns? General statements? All right. So then let's rock and roll. Okay. The 4 was in the problem. Secant 7 over 4 is the same as cosine of 4 over 7, right? Isn't that just the flip? So we drew our angle, and we did cosine. Cosine is which two sides of people? Very good. Adjacent was the 4. Hypotenuse was the 7. That's why we use those. That helps you fill out your triangle.
Oh, now we understand. We have to find what we recommend.
Yep. Yep. Next problem. Determine the phase shift. Leslie, what's this problem going to look like? You're thinking horizontal shift. A phase shift is more specifically a what kind of function? I will accept the big T word. I will accept the specific names of those two functions that we studied. You want to phone a friend? Chris, she's phoning you in. What kind of function is this going to be? Katie Beth, they're phoning you in. What kind of function is this going to be? All right, we're going to keep going. Ryan, they're phoning you in. What kind of function is this going to be? It's going to be a trig function, some kind of sine or cosine. I never call for the people who want to be called on. That'd be too easy. Can you imagine if I coach like that? Coach, put me in. No, you go in. But I'm not even dressed. Anyway. Phase shift is trigonometric functions, or sine or cosine is what I would have accepted. This one happens to be cosine. What is the formula for the phase shift of a function? Negatives. I bet you are the kid who's always asking to go into a game, aren't you? Ooh, coach, put me in. Okay. You wouldn't do it in that voice. All right, negative C over B. Holly, what are my negative C and B values? It would. Negative, pi over 2, which would make it positive. And then my B? Well, the X is like the angle, so we leave that there. So would that be negative pi over 4? Negative pi over 4 takes you to the left or to the right? Okay, I see why you say that, because I'm always like, do the opposite. But the negative is kind of already done. The negative has already done that for you. If you want to think about, okay, here's the easiest way to think, does it go to the left or the right? Remember how in the old days, if it was x minus 2, you went right. If it was x plus 2, you went left. Is this originally a minus or a positive? It was a minus. Actually, it's not entirely true because that's a negative. All right, new plan. The negative C has already done the opposite thing for you. It's already done the, if it's negative, switch it to positive, but it's already done that for you. So whatever this is, just think of it literally on the x-axis. Negative takes you where on the x-axis? Left. So it would be D. I know that's confusing because I always say do the opposite, but the negative has already accounted for the opposite. So it would be D. Pi over 4 units. To the left, to the left. The 4 came from when you did your C over B. That became, when you flip and multiply, that's times negative 1 over 2. Pi over 4. Yeah. Of course, if you ever have just like a 3-layered fraction, you always just multiply the denominators. That's kind of just the shortcut. If it's just a fraction over a number, you'll just multiply them. Questions? No, it's still there. Well, again, negative pi over 4 is how we knew it went left, because negative is left. Well, it looks like, see, I would have preferred the answers just be, like, without all this to the right, to the left stuff, pi over 2, negative pi over 2, pi over 4, negative pi over 4. But instead of putting the negative, they included the left and right. Left is negative, right is positive. Yeah. So that might be something you write down. Left is negative, right is positive. Number 13. Convert the angles to degrees in radians. Well, that's pretty straightforward. I'm not even going to beat around the bush. Sarah, do you happen to remember the formula for converting angles to degrees, or from degrees to radians? Who has it a little bit more at the ready, right in front of them? Latifa. Yes, it would. What is negative 150 over 180 reduced to? Negative 5 over 6, thus D. You guys are rocking out on this thing. That's exciting. Questions? And of course, if it had been from radians to degrees, it'd be 180 over pi. Next question. Begin by graphing the standard cubic function. Okay, blah, 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 blah. This whole thing is graphing a cubic function, so let me just get to it. Alright, parent function is on all four of them. You don't even have to know it. The parent function, I know it's kind of hard to see where you're at, is that little parabola right there on all four of them. All you need to know are what's happening to it. What are the shifts? One of these. Right. It will be mirrored, so it'll be flipped. Well, what are the actual shifts being done to it? Yes, sir. Right 5 down 2. Right 5 down 2, which could be A, C, or B, but then it's being flipped. Now it's being flipped vertically, horizontally. Even if you don't know the answer to that question, punch it in the calculator and look at it. Well, we know it's not C. That one's not flipped at all. So it has to be A or D. Is it being flipped this way or this way? My memory serves that the negative in the parentheses is this way, and it's outside the parentheses this way. But I've been wrong once or twice before in my life. So, actually, these are both flipped the same way, aren't they? Just one of them is extremely stretched. So actually, we know which way. What? Well, how did you get these? I mean, was that the stretched one? Oh, then by that observation, then yes, you'd be right. I guess a safer way to do it would just be try a coordinate. This one looks like negative 2, 0 is really, it's not on the function, it's really darn close. Whereas this one at negative 2, you have a ginormous y value. So you could just punch negative 2 into the function and see what you get. That's a way you can check tomorrow. Just take a random point. So like negative 2, that would be negative 7 cubed, wholly natural, negative number. So a negative ginormous number minus 2, negative a negative, so it'll be a positive x. So actually, it would be, yeah, you're right, B, negative 2 ginormous number. Punch in a value, see what you get. Good job. Questions on that problem about any conclusions we came to, how we knew to do something?
Okay. All I know is I punch my calculator.
Okay.
And how do you get the second?
What do you mean the second one? The graph?
The flip.
What did you punch in the calculator?
Or the, what am I looking for?
Hold on. Did you punch that into the calculator?
Yeah.
Okay. So you got that it turns this way, right?
Mm-hmm.
That's how we knew it had to be A or B, right? Now, Chris, noticed, hey, this one looks about the same as this one, and there's nothing being multiplied, so that should be right, whereas this one looks wider. Now, a safer way to do that was look for a coordinate that's drastically different on both of them. And I was like, well, it looks like it almost touches, actually that'd be negative 3. It looks like it almost touches negative 3 here at 0, but over here at negative 3, you have like a big number. So you graphed it, right? Hit trace negative 3. Now, before you tell me what it is, if you get a big positive number, then it's going to be B. If you get like 0 or really close to it, it's going to be A. There you go, big number. So when in doubt, you can trace values to see which one's actually closer.
But how do you know, like, after you get the big number, how do you know it's going to be different?
Because I was looking at the graph. At negative 3, this one has a y value that's not even on the chart. Whereas this one, at negative 3, it's like right there. You just have to look at the actual graph and compare and contrast the values.
Okay.
Now, I wish they had given you the whole line as the one you were actually looking for. It's kind of hard to see these. But this will be easier on tomorrow's test. Well, Alpner thinks easier on this test. Questions? Find the domain. What's it going to look like? What do we have to do? Sam, what's it going to look like? Looks like a write-up for sleeping. What's it going to look like? Oh. Okay. It's a function, and you have to check whether that function is going to be impossible. What do we do with things under a radical? Somebody who's not going to panic when they answer.
So you have to set it equal to 0.
Greater than or equal to 0. You said like 18 things, Nate. How was I supposed to know which one was right? Alright, so add the x. So x has to be less than or equal to 6. So negative infinity to 6 with a bracket. So that would be a. Yeah, it can be 0. Now, this was a problem I remember on one of the tests we had that threw a lot of people for a loop. It was 1 over, and then it couldn't be 0 because it would be in the denominator. But you can have a 0 under a radical. That's perfectly legal. Yes, sir. Well, this says it has to be less than 6. So, yeah. Questions? All right. Divide and express the result in standard form. Tanner, I just noticed you're back. You've been gone forever. What do I do? I heard a mumble. Normally mumbles mean I'm not entirely sure. You want to phone a friend? Jalen, what do I do? Multiply it by the reciprocal. So, on the top, that becomes 2i plus 2i squared. And on the bottom, that becomes 1 minus I squared. What is I squared? Negative 1. So that's 2i plus 2 times negative 1, so minus 2. And then 1 minus negative 1 becomes 2. So is it I minus 1? Which would be, where's I minus 1? Why isn't the I negative? Right, I minus 1. Sorry. Standard form. Number comes first. Good catch. I started to freak out a little bit. Sorry, didn't register. Questions? Do I click on? $21 today, 23 tomorrow. Point of the terminal side of the angle is given. Find the exact value of the trig function of theta. Getting a little weary of the game, so we're just going to jump straight to it. Negative 3, negative 2. Why does it benefit you to graph it? That's right. Negative 3, negative 2. Connect it to the x-axis. Of course, I guess it gave us both pieces were negative. The hypotenuse will always be positive. You can do Pythagorean theorem and get radical 13. We are asked for secant of theta. Flynn, what's secant the flip of? That's right. And what would cosine of our angle be here? Very good. And then for secant, we flip it. So it'd be radical 13. That's a 3, by the way. Radical 13 over negative 3, which would be bravo. Some of you are going to find cosine and then rationalize it before you really even think about flipping it. Just think. Since you're flipping it anyway, don't bother rationalizing cosine. Radical 13 over negative 3. Marked on my chest. I'll let it slide. Questions? Questions? Alright. Graph the function. What is the easiest way to graph this? Now, even better, when you punch it into your calculator, make sure your window matches the window of theirs. That way, you don't have to translate what you're looking at. Also, make sure you're in radian mode. When you graph these on your calculator, you need to be in radian mode. Clear. Negative 3/4 cosine 2 theta plus pi over 4. Now, before I hit enter, I am going, oh, I forgot my, no I didn't. I'm going to go to my window and set it the exact same as theirs. So it looks like theirs go from negative pi to pi. And looks like from about negative 2 to 3. Are there any questions before I hit graph? It's given on the picture. All of them go from negative pi to pi and then negative 2 to 3. So, I can tell it's A or D, so we have to find a subtle difference between them. This one has a y-intercept below the origin. This one has a y-intercept above the origin. Which one do we have? So it is the easiest way to do it, right there. Graph it, look at it. Questions on that one? It was A. It looked very similar to D, but what we did then was we looked at the y-intercept and saw that that one matched. You just look for any reference point that helps you make a conclusion. Does that make sense? Is yours still in degree mode? And you changed your window? Interesting. Maybe you missed a negative. Oh, here's why. What about? Oh, you have 3 or 4 factors. Okay. Questions? Does it look better now, Bridget? Number 19. Use periodic properties to find the exact value of the expression. AKA, Mr. Powers, what do we have to do to this before we can find it on the unit circle? That? You could convert it 2 degrees. That is always an option. That is always an option. Zach, what should we do? We should subtract 2 pi. Very good. But if you did degrees, that would be actually even easier, and you could subtract 360. So subtract 2 pi, which is 6 pi over thirds. So that's 4 pi over thirds. And on your unit circle, what is cosine of 4 pi over 3? Click. Should be negative. We know that. Negative 1/2. Now, you could also just punch that straight into the calculator. And cosine 10 pi thirds, it would tell you negative 0.5. However, it's probably still smart to do it on a unit circle, because if they had negative radical 3 over 2 and negative radical 2 over 2, the calculator is going to give you a decimal. So, to spare yourself having to possibly convert those into decimals, you could just look straight on the unit circle. So in my opinion, that's still the easier way, but it's up to you. If you were to punch this in the calculator, what would you need to be in? Very good, radians. Do I need to leave this on the board? Number 20. Sine and cosine are given. Use identities to find the indicated value. They tried to pull a fast one on us. Now, technically speaking, the smart way to do this would be to draw. In fact, we're still going to do it like that. Although, while I'm drawing this, why is it unnecessary to draw this particular problem? What's that? Yeah, all you cosecant is just the flip of sine. So it'll be negative 7 over 2. You don't even need the cosine. they happened to ask us something that would straighten the problem. Cosecant is the flip of sine. However, what if they had asked you for tangent or cotangent? We'll pause that for just a second. Sine is opposite. I can do this. Opposite over hypotenuse, and adjacent is adjacent. Cosine is adjacent over hypotenuse. So, easiest thing to do is once you've plotted your triangle with the use of your trig functions, like if they had asked you for tangent, that'd be opposite over adjacent, or cotangent would be the flip of that, or whatever. In fact, I'm pretty darn sure that the one I picked like this for tomorrow was a tan or cotan problem, so you can't just flip something given to you. So please make sure you know you have to use these to draw your triangle. Are there any questions about where we got anything on that triangle? Cotangent, yes. Yes, it would. No, yes. Yes, it would. Why are bananas popping up on my board? What is wrong with you? Someone is so hyper. What? I guess you probably still could do that, yeah. Yes, you could. Yes, you could. Alright, 21. Last one for today, but there will be 23 tomorrow. Find a positive angle less than 360 or 2 pi that is coterminal. What's this going to look like? What do we have to do? It's going to be some kind of angle or radian, degree or radian angle, and we have to either add or subtract 360 or 2 pi. But knowing as mean as I am, I'm almost positive I probably gave you a radian. And I did. I wouldn't give you something as easy as degrees. So, what do we add to it, Mr. Peoples? 2 pi was the one you asked, so I thought I'd ask you again. What is 2 pi in terms of ninths? Zach? 18 pi over 9. Negative 7 plus 18? 11. I was quoting the boogeyman from Nightmare Before Christmas right there. Snake Eyes! Mwah! Anybody seen that, Nightmare Before Christmas? It's like one of my favorite movies. Nobody's seen it? Thank you. And then he bangs it. Okay, forget it. Never mind. Just kidding. Any questions about any problem we've done today or about your test in general? Yes. Nope. Everything that you'll have tomorrow will be almost exactly like what you've seen today. I'm just theorizing here, but for the 2 extra questions, you might have a horizontal and slant asymptote problem that weren't on there today, but were on your review yesterday. Maybe. Just maybe. What? Extra 2 slides. We're not going to do them right now. Okay, if there's no questions, then this has concluded